Hey guys, today we'll be doing lead code number 2078. This is the daily problem for today. It is 20th of April. This is an easy question as well. And so let's start this off with the general explanation of the question first. I'll take an example from lead code right here. If we had this array, what they want us to calculate is essentially places where colors at that point, essentially such that like if we had a different index j and we had a different index I, those two should not be equal, and when they're not equal, all we have to do is calculate the distance between them, right? And we have to find the maximum distance because the furthest implies maximum. Okay, and there's two ways to approach this question, right? But what I first want you to understand is the furthest can come from either 2 points, right? If you think about it, right, the furthest could be this and this, right? The farthest left side and the farthest right side, that would be the most ideal solution, right? R minus L in this case would basically be n minus 1. Okay, and all we have to do is, right, we have to consider that exact scenario, and we can see that, okay, if we go this way, right, if we go this way and we go this way, so left to right and right to left, if we calculated the distances, the maximum distance would, well, there is actually the code that I'll write, it will show you one full direction, so going left to right. If you calculated left to right, the distance, you would essentially do like a brute force version where you would see like the difference. You would hold your left as your, like you would hold your right as your anchor, and you would move your left 1 1 1 1 1. Okay, and the next one where it is right to left, we would hold our right constant, we'll hold our left constant, and we would move our right 1 by 1 1 by 1, checking the value 1 by 1. Okay, if I wrote this out plainly in code, this algorithm here going left to right, so if we did L as being 0, R as being the length of the nums minus colors minus 1, sorry, right, we would let, so left to right, we are gonna increase our left, we're going to increase our left, remember that. Okay, so if the number colors R in this case is not equals to colors L, okay, so both of them are not equal. When they're both not equal, we have to do this formula. Okay, so we will say we'll declare a local variable answer equals to 0. We will simply just do answer equals to max of answer at that point, and R minus L. You don't even have to do ABS because R will always be greater than L. That's how the code is literally written. So R will always be greater than L, and answer is just max. We've stored that, right? And like I said, we'll move our left always. Left plus equals to 1. If they are not equal, no worries, we'll still move our left plus equals to 1. Okay, so if you get what I mean, essentially what I'm saying is, if we had 6 here, we had, let's consider this to be 1 as well, and if we had 6 here as well, okay, So if we do 6, we were holding this and we were holding this, right? And we're going left to right now. Our pointer is held at R. We have another one at left. We will just move one ahead. We will ignore this 6 and 6 because, well, they're equal, right? So we will just move one ahead. We'll keep following the direction we're going to. Now we'll do another one. We can do another loop. Okay, like I said, another direction, right to left. So L is less than R if colors again, if they're not equal, same thing, answer is just the maximum. But now the difference is we will decrement our right pointer instead. So like I said, we will move 6 here, we will move 6 here, like that, okay? And if they still don't match, then just simply decrement our right pointer. If you return the answer here, we would get the correct answer already, okay? But now there's a way to write this more efficiently, okay? Because what I've done is written out the O of n both ways, going left to right, right to left. There's a shorter version of this code, okay? This is a good intuitive version, I would say. Intuitive in the sense that this is probably something you would come up with, and pretty easy, I would say. And O of n, the other one as well. This one is even more simpler, I would say, because the code is shorter and it plays the same trick. So if we just do a simple for loop for I in range len colors, okay, we do the same condition. If colors I is not equals to colors j, okay. Now the thing is that we will do, okay, the thing that we do is we will simultaneously collect information for both our left and our right at the same point. If you get what I mean, I'll show it the best way by doing it in the middle, right in the middle. Hypothetical scenario here. If you consider 1, 1, 1, stuff like this, if we were sitting at the middle, okay, and let's say we would calculate the farthest from our this side, farthest from our this side, essentially that's what we're doing. So when we loop through this array, we'll hold two constants like we did with L and R. We'll hold two constants, no worries. We'll hold n minus 1 and we'll hold R0, but we'll move our one pointer ahead, move it ahead, move it ahead, right? And when we hit any point that's, well, let's say not equal to the one on 0, we will calculate the distance simply. If it's not equal to n minus 1, we'll calculate the distance. This way we can keep a track of, both sides at the same time. It's just a more efficient version of this, because even in this we hold L and R to be the constants, and we move L in one case, R in the other. Now we just do distance calculations simultaneously. So answer in this case would simply just be maximum colors j actually would be 0. Sorry. So yeah, like I said, I is 0, j is 0, sorry, j is 0, and j can also be n minus 1. I'll show you what I mean. Answer, and the difference between I minus 0 is just I, so you could write it as I, there's no issues. Now if we see, and this is crucial by the way, we write it with an if, not an else if, because, well, that number that we are on can be not equal to the left, not equal to the right. It can be completely separate, right? So we would like to calculate both distances for either end. So if colors I is also not equals to colors minus 1, so this is a trick in Python that gets you the last element. If not, you can do len colors, store that as n, and then over here just do n minus 1. Okay, that's another way. So if that is not equal as well, then answer is just the maximum between the current answer and n minus 1, which is our r, right, minus 1. Okay, minus I, sorry. So this is essentially like doing the r minus l over here, and over here we've already held it to 0, so I minus 0 not really needed, and at the end just return answer. There's another brute force approach to it, O n squared. If I had to show this very simply, it's just pick each number and then run another loop for another number for j in range. Run this from I plus 1 to n, this from up until n, I plus 1 to n. Calculate the answer to be the maximum, well, if it is not equal, and then just do answer as just the max between the answer and the j minus I at that point. Okay, and then return answer. The brute force is, okay, this is probably the first ever one you would ever come up with. This one left to right is something you can think of, and this one is just like the most clean code, if you could say. But that's it for this question, really. I would classify it as 2 pointers, greedy. It's really just coming up with the one strategy that, so this strategy of holding these constant pointers, and it's just that essentially.